Hey everybody, welcome to this Hackerearth webinar on machine learning in a live production environment. I'm very excited to be talking with all of you today and sharing the knowledge and insight that I've gathered over the course of quite a few years on how to go about writing machine learning projects. I'm very excited, and again, thanks to Hackerearth for putting this on, and thanks to all of you for showing up. Throughout this talk, we'll be talking about quite a few different things, and we'll get into that. But the thing to realize is that I won't be going into any particular depth when it comes to machine learning algorithms or even the code. Instead, I'm going to leave it somewhat at a philosophical level so that you can get the information necessary to delve deeper and to learn more about machine learning. My goal really is to get you excited about this wonderful subject because there's so many applications, so many ways that you can use machine learning in your daily life or in what you do in code. If you're interested in delving a little bit deeper, I did write a book called Thoughtful Machine Learning with Python. It's basically it's a book that I wrote a couple of years ago, Thoughtful Machine Learning, which was written in Ruby, and I've completely gone through it, rewritten a lot of it, all in Python, and updated a lot of the chapters and added some more. So if you want to delve even deeper and to learn the algorithm design or how to write the code, then I do recommend that you check out this book. But today, we're going to cover quite a few different things. I'm going to go over these different topics. And then towards the end, I'm going to open it up for questions because I really want to hear what you think. And so keep those questions in mind, ask them throughout the webinar, and towards the end, I'll do my best to answer as many as I can. We're going to cover, first of all, why use machine learning in the first place. We're going to talk about when to start using machine learning and when not to. And then we're going to get kind of more into the production quality things. So we will talk about which platforms exist for writing machine learning code, which algorithms exist, so really giving you the information necessary to know which algorithm type to go for. And then finally, I will introduce to you a process for delivering production quality machine learning code. Now, the goal, again, is not to go into any particular depth when it comes to math or writing the particular code. Instead, it's to give you some ideas and to give you really the terms to look for. I hope that by the end of this, you'll have enough information so that you can go off and learn more. And then also, going back to the whole point behind the book that I wrote, I believe that machine learning is not unlike writing regular software. So having a process or a mindset is really essential to going about writing machine learning code. So let's start at the top. Why use machine learning at all? Now, a lot of people have heard the term machine learning thrown around, or deep learning, or autoencoders, TensorFlow. You've probably heard all of these terms thrown around. Naive Bayesian classifiers, support vector machines, the list goes on and on and on. Machine learning, for those of you who don't know, is really a pretty new field in computer science. It's really a way of taking data and doing something with it. And it's become very popular because of how you can apply it to the massive amount of data that we have at our fingertips. Today, it's very easy to store tons and tons of information. You're able to store gigabytes of information for cents on the dollar. Many years ago, we couldn't do this because a gigabyte of information cost quite a bit. But machine learning really comes into play with what exactly do you do with all of this data? So to introduce it, I thought that I'd use an example. And to explain it, I have something called the DII pyramid, or the Data Information Insight Pyramid, which really serves as a hierarchy of needs or a way to think about how to build a successful data-driven project. So at the bottom, we have data. Data is really essential. Data is really what we need. Now, data is also quite granular. So to use an example, it could be something like the current temperature throughout. Now, we're collecting temperature all throughout the day, and it could be 20 degrees Celsius or 10 degrees Celsius or whatever, and you'll end up with thousands and thousands of data points. But that isn't really that useful. Well, maybe the current temperature is, but what temperature it was at 3 in the morning doesn't matter as much. Which gets you into the second tier of data reasoning, which is information. Information is where you take all of these data points and you aggregate them somehow. So for instance, using temperature, it could be the high, the low, the average, the median. That is information, and it's really useful. Any sort of weather forecast will tell you the highs and lows and the barometric pressure throughout the day. But all the way at the top, you have insight. Insight is really where machine learning comes into play, and this is why you use machine learning. Insight is where we take all of the information and data that we've collected about weather and start to make some answers off of it. So is today an exceptionally hot or cold day, or has it been a weird day? These are questions that we ask about the current day, and with a machine learning model, or in this case weather model, you can start to gather these insights. And this is really where machine learning comes and dominates. Imagine if you had a plethora of emails and you want to do something with it and derive insight off of it, you most likely have to use a machine learning algorithm. The other benefit of machine learning is that it's very similar to probabilistic programming, which is this whole idea that instead of a bunch of ifs and elses using manual code, instead you write based off of the probability of something happening. So in my little graphic right here, you see the bunch of ifs and elses. On the right, you see bug, which is a very probabilistic logic-based program. Now, the benefit of this when it comes to software development is that we're able to concise down insight into a much smaller piece. So utilizing machine learning algorithms would be able to do things a lot easier than just a ton of ifs and elses. On top of that, using machine learning is all about automation. So we as humans, of course, can go through and tediously mark things as true or false, or say it's spammy or not. But if we were doing that all day long, then we'd be most likely wasting our time. Machine learning gives us the ability to automate some reasoning that we inherently have in us. So with tools like Siri and Cortana and Alexa, you're able to just talk to a machine and have it do the work for you as opposed to typing something in. And this is really why machine learning has become so important. So we've talked a little bit about why machine learning, which I think is always important to start with because we need to understand the entire point behind using machine learning code rather than just delving in and trying out some examples. Next, I'm going to start talking about when you should use machine learning versus when you shouldn't use machine learning. And this is very important as well because sometimes when it comes to writing good quality production code, it's knowing when to write it versus when not to. Sometimes the problem that you're trying to solve is just really hard to solve. But let's talk about when you should use machine learning. When you should use machine learning really has to do with the fact that there's a discernible pattern that exists. Now, this can be any pattern. It could be a bunch of images with cats in them. It could be spam filtering. It could be this jazz music. It doesn't matter, but there needs to be some sort of pattern that you're trying to exploit. The other thing is that the data is accessible and queryable. And you have to have most likely more than 1,000 data points. Now this is really important because machine learning usually relies on statistical variances, and if you don't have a lot of data points, then most likely your results might be spurious. You also use machine learning when you're trying to classify insights, predicting a nominal value, tagging data, determining a strategy to use previous data, and much, much more. Machine learning is really just a toolkit of algorithms that you can use to solve many of these problems. And we'll get into the different algorithm types and which type to use for what type of a problem later. But now we need to talk about when not to use machine learning. Now, when a lot of people start machine learning and they start learning machine learning, they think that it's pretty much, it's a hammer, and everything starts looking like a nail. And machine learning is not a silver bullet. It can't do everything for you. In a lot of ways, machine learning is also like software, and you have to overcome the initial sunk cost when it comes to machine learning, writing the machine learning code, tweaking it, configuring it. But overall, when not to use machine learning is really comes down to you don't have enough data. That's a really important point to make, is that if you don't have enough data, then most likely machine learning is not going to help you there. If you don't have domain knowledge, and I'll explain what domain knowledge is, then also most likely you don't want to start using machine learning. Domain knowledge is really whether you understand the domain or not. Now, you don't need to be an expert on it, but you still need to understand the concepts behind it. So for instance, if you're building a Q-learning trading algorithm for building portfolios, then you need to understand what a portfolio is, how they're constructed, anything like finance terms. So it's important to understand the domain. Thirdly, classifying data that isn't agreed upon by humans. Now, this is something that you'll see quite often, is that when you start to look at certain problems, humans disagree on the answer. Now, generally speaking, machines are no smarter than human beings. So therefore, asking a machine to come up with an answer that humans don't agree upon is generally a bad idea. So if humans don't agree upon it, then while you can do some tricks to get close, it's probably a good idea to try a different problem, or really to rethink the problem. And lastly, the data is inconsistent. Now, this is really important for something like weather. So if you have winter data points next to summer data points, then most likely your model is going to be really chaotic. So the data is really inconsistent. If your data is inconsistent, then either you need to sample data effectively or figure out some sort of way of filtering out the outliers. All right, so we've talked about why use machine learning. We've talked about when you should use machine learning versus not. But now, platform. What are the ways, or how can you actually write machine learning code? And there's a few different platforms. Of course, there's probably more that we could come up with, but 4 major to think about when you're starting a machine learning project. And they are Python, the JVM, Spark, all of those tools, Mahout, those sorts of things. Then you have R, MATLAB, Mathematica, kind of the statistical languages or the mathematical languages. And then finally you have homegrown, which is something that you've built yourself. Now, each of these have their benefits and cons. I'm going to go through each one of these individually. Python, at the very top, is probably the most popular stack when it comes to learning machine learning code. And it makes sense because Python is adopted well in academia as well as in the industry. So generally speaking, it's a good idea to use Python. It's also a pretty good language to pick up. It's not super difficult. It's an interpreted language, so most people can learn Python fairly quickly. So if you're just trying to learn machine learning code, then Python's probably a pretty good option for you. I'm a little biased to Python in that I wrote my last book in Python, so therefore, I think it's a really good choice. It's also I think Python's a nice language. It works really well, and it's pretty easy to get. The con to Python is really scalability. Now, of course, you can scale Python, and you can do things to make it scale. You can actually hook Python into Spark for distribution of load. But the issues are, there's definitely issues when it comes to Python. It's an interpreted language, so therefore it can be kind of slow. at times. It also has a GIL, which is a global interpreter lock, meaning that any sort of threading in it can be kind of difficult. And on top of that, it can also take up a lot of memory. So Python is sometimes not great if you need a lot of scale. Now, if you're just getting started with Python, check out SciPy, scikit-learn, NumPy, and Pandas. Those are all really great ways to start learning machine learning, and scikit-learn especially. Okay, next we have the JVM, which the JVM's biggest benefit is honestly scalability. Many different companies like Amazon, let's see, Amazon, we've got Twitter, I believe there's quite a few other companies that use the JVM to massive, massive scale. The ability to distribute load over commodity servers is easy with the JVM. On top of that, it has a really good garbage collector. It threads exceptionally well. And on top of that, the JVM has a ton of languages that you can check out. You can use Ruby, you can use Python, you can use Clojure, of course you can use Java and Scala. So you have really a lot of flexibility when it comes to writing the code. Now, the downside with the JVM is that it can be kind of a system administration nightmare occasionally, depending on how you have things set up. Of course, that's getting easier now with things like AWS and chef recipes and all of that, but it can be kind of hard to set up and get started with. So sometimes it's not a great language to get started just diving in learning. But if you need the scalability, then the JVM or Spark is probably a great idea. Okay, next we have statistical computing, which is R, SAS, SPSS, MATLAB, Mathematica. There's quite a few more. These are really great for prototyping, but not super great at integrating with anything else. So R, for instance, has excellent regression analysis, machine learning algorithms, and its visualization capability is really almost unbeatable. Being able to do stuff in ggplot is very, very good. If you're just learning machine learning and you don't need to deploy it anywhere, then these are great languages. They tend to not be good languages if you're trying to integrate with an API or a database or other code. So if you're actually working in a production environment, trying to build scalability or trying to build like a good code base, then these are probably not a great option. But they're really good for prototyping. Okay, last we have homegrown. Now these really happen when you need flexibility or you need a ton of performance. So what I mean by performance is not scalability, but just pure bare metal speed. With homegrown, you can build things in C and C++ libraries. You could use Ruby. I wrote my first book in Ruby. Lua, Go, JavaScript, Node.js. Now, the benefit here is that you get all of the flexibility. So for instance, if you are a hedge fund and you want to write the fastest code possible for your high frequency trading algorithm, then most likely you need to write it in C and C++, or maybe Go or Lua. It gives you a lot of flexibility, but the real downside to homegrown is that there's an immense amount of maintenance cost as well as it's expensive to implement. You have to build everything yourself or glue things together based off of what you can find. So there you have the four major platforms. I want you to just look at these, think about how this relates with your organization or what type of projects you're working on. And I think that the platform will kind of be obvious depending on which type of project you're working on. If you're just trying to learn machine learning, then Python's probably good. If you need a lot of scale and you're working with billions of rows, then most likely the JVM's good. If you're running a hedge fund, then homegrown's probably the best solution. Now, of course, don't forget about R. I think R is also very good too, but it's not really meant for a production environment. Okay, so we have talked about why machine learning. We've talked about when you should use machine learning. We've also talked about how to go about writing machine learning code, so which platforms to put it on. But we haven't talked anything about machine learning algorithms themselves. Now, I'm not going to get into any sort of mathematical definitions around machine learning algorithms. I'm not going to go into the construction of them, but I do think it's important to explain the three major classes of machine learning algorithms. And I'm going to go through those one by one. At the very top of algorithms, really the most popular algorithm class out there is supervised learning. Most likely, if you've heard about machine learning, you've heard of supervised learning algorithms. So the classic example is spam filtering, where you have a bunch of data that somebody has tediously gone through and marked as either spam or not. And you want to build a model such that you don't have to tediously go through the emails and mark them as spam or not. You just want a computer to do it for you. Now, you can use many different supervised learning algorithms, but most likely you probably use naive Bayesian classifier to do that because that's a classic example. But you could use others, k-nearest neighbors, support vector machines. Neural nets have become very popular recently with TensorFlow. The idea behind supervised learning is that you have data that's an X and a Y. So you have inputs and an output, and you want to build a model around that. That's supervised learning. So the idea is that supervision is when you say, I'm giving you the answer. Now build a model. So that's probably the most popular machine learning algorithm, but it doesn't necessarily mean that this is the right model for what you're working on. So that gets us into the second machine learning style, which is unsupervised learning. Now, going back to the email example, let's just say that we don't have time to go through all of the email and mark it as spam or not. We really just want to group emails together, or we just want an algorithm to tell us about emails, regardless of what we have given it. We don't want to supervise, we don't want to do any sort of extra legwork, and that's where unsupervised learning really happens. The idea here is that there is no Y. It's just Y is in the letter Y. There's just all X's. So there's just data. So you have a bunch of emails with words in them, and you want to learn the different clusters. So for instance, it could be that there's many different types of clusters, not necessarily just spammy versus not spammy, but you could split it into two different categories. Examples of unsupervised learning are autoencoders, which are kind of a subsection of deep learning where you often use a neural net to come up with features, clustering, which is just grouping data into different clusters, and then matrix factorization, which is taking the same matrix of data and then collapsing it in on itself. Okay, so reinforcement learning. This is an algorithm class that doesn't get talked about nearly as much. And to explain it, let's go back to the email example. Let's say that instead of trying to just analyze emails, or instead of trying to do spam or not spam, what we want to do, let's say that we are an email service provider or a marketing company. And I work for a marketing company, so this is near and dear to my heart. Let's say that we want to build a tool that maximizes something over time, given that we've sent off a couple of different emails. So for instance, we could say, hey, we've got an email list and we want to send off an email once in a while to maximize how much they pay me. Or it could be maximize deliverability or maximize people not unsubscribing. The idea is really the same, that you want to maximize something over time or minimize. Reinforcement learning is the class of algorithms that solves this. What these algorithms do is really, truly amazing. Think of it this way. You're basically playing a game and you're trying to win the game in the end, which is the long-term reward, but you're trying to make different decisions over time. and you want to learn what the optimal policy is for those decisions. Now, this is kind of more of a new research area. There's a lot of interesting new research going here. I highly recommend checking it out. There's some neat stuff around Q-learning, TD lambda, multi-armed bandits, where you can apply this to either things like advertisements, or even if you want to play Super Mario Brothers, you can use Q-learning to beat Super Mario Brothers, which is so interesting. So those are the three different types of learning styles. And I really don't want to get into any sort of depth with these because I do talk about these things a little bit in the, not all of them, but quite a few of them in my book in more depth. Or you can check out some interesting articles on it, or I do recommend like looking up some talks on algorithm design and how they're built. But the idea here is to give you the three categories so that when you're approaching a problem that you're trying to solve, like an actual fundamental problem, you can determine which class it is. And from these classes, you can branch out to find a couple of different algorithms. And the important thing to realize here is that these algorithms, most of the time, are interchangeable. So whether you use naive Bayesian classifier versus support vector machines almost doesn't matter. What really matters is how they perform, which we will get to in the next section. All right, so we have talked about why use machine learning. We've talked about when you should use machine learning versus not. We've talked about how you should go about writing your machine learning code. And we've talked about algorithm classes. Now, this is a lot of setup for what is really truly the crux of this webinar, which is delivering production quality code using machine learning algorithms. Now, I'm going to get into a delivery process, and I'm going to go through each thing one by one, but the goal here is really to set you up for success and give you the information that I have learned over the last few years. And I hope that really you just take this information and run with it. So if you hear a term that you haven't heard before, go check that out. And when you're going about writing your project, take this delivery process into mind. All right, so I stole this title from Git flow, but the idea here is that this is a flow that you can utilize to write production quality code. Really, my point here is that things are not one and done. Machine learning is a highly iterative process where you start off kind of in a baby state where you're trying to beat the 50-50 chance. So if we're building an email spam classifier, there's a 50-50 chance that if we randomly pick between the two, we'll be right. So we want to beat that somehow. In the beginning, we might say, okay, we have no assumptions, so we have a 50-50 shot of being correct. But we want to do better. So you state a hypothesis like maybe naive Bayesian classification will work better. Now from there, you branch off the existing model if it's there. In this case, it wouldn't be there. And you want to test your hypothesis. So with naive Bayesian classification, we get some training data. We pull it down into our local environment, and we do some stratified testing. So the point here is you take a training set and you split it into multiple pieces, like 20%. And what you want to do is you want to train your model given 20% and then test using the other 80%, or maybe vice versa. This is called cross-validation, and the idea is that you take the training data that you have and have some training and some testing so that you can come up with an accuracy or precision or recall based off of the model. So let's say that we started out with no model and we have a 50-50 chance of being spammy or not, and we say, okay, we want to do naive Bayesian classification, and we've determined that 80% of the time we'll be correct. Well, that's actually fairly good. It's a It's a good increase over the original assumptions, so therefore we compare it with the existing model, which we have none, and it's better, so therefore we merge it in and we use that for a little bit. Now you can keep doing this in your development environment and basically keep iterating until you have a fairly good model over time. Now, what I mean by iteration is that originally you will do an algorithm, and then you might try some sampling techniques like bootstrap aggregation. You might try some boosting, or you might try matrix factorization. There's a lot of interesting tools available to iterate off of an initial model. Or it might be that you just need to find very good data. Now, this is very similar to the scientific method, where you state your hypothesis, you test it, and then if it's better, then you kind of get closer and closer to a theory. And what I've found is that the scientific method is also very similar to agile or development process. So when I get a ticket out of Pivotal Tracker or Jira or whatever project management tool that I get, really there's the ask or the hypothesis, and I test it using unit tests and integration tests, and I send it up for a pull request for peer review, and then eventually it gets merged in and deployed. The point that I'm making here is that writing machine learning code for production is really no different than writing good quality production code. Now, of course, you have to understand machine learning, you have to understand the algorithms, you have to understand when to use it, you have to understand how to use it, like which types of programming languages you can use, but it is still just software development. All right, now I wanted to talk a little bit, take this even further. Now, this is a really important point about machine learning code, is that while you might have a training set that you've utilized and you've got 90% accuracy rates and everything looks really great, you deploy it to production and then users start to wonder what is wrong with you. Testing in production is absolutely essential to the success of a machine learning project. Google, Facebook, all of these companies do this, whereby they're gathering insight as to whether their initial assumption is correct or not. Think of this as monitoring. So you want to monitor how something works in production with your code, and you want to be notified whenever an exception happens, of course. Now, there's some ways to do this with machine learning code, which are actually quite interesting right now. There's LaunchDarkly, GitHub Science, homegrown solution, which really is just something that you wrote yourself. But the idea here is that LaunchDarkly is really a cool tool. You can take your users and split them into categories and say 10% of them are going to get the new model, whereas 90% of them are not. And take that information and determine how well it performs in production with real data. On top of this, I believe that it is also really essential to constantly be pulling new data. A lot of the times machine learning projects fail because while they worked at one point in time, they're not dynamic with how things change. Realistically, data and people's minds change all the time. I mean, if you don't believe me, just look at the stock market. It's very important to make sure that our models stay up to date when it comes to the data, because things change. So that's why tools like LaunchDarkly, GitHub Science, or some sort of homegrown solution are really essential to iterating off of the original assumption. All right, so we've talked about quite a few different things. I'm going to go over what they are, and I'm going to wrap up here, and then we'll do some questions. But basically, I want you to take away these major insights, which are really only use machine learning if there's a good reason to use it. A lot of the time, machine learning gets touted as a hammer searching for a nail. It makes sense. We take data and turn it into insight and that could be applicable just about anywhere, but it's always good to know when to use it versus not. Secondly, pick your platform accordingly. Your organization might be a place that requires everything to be on the JVM. In that case, write it on the JVM. But if it doesn't, then maybe Python is better for you, or maybe you need to use a homegrown solution. But understand that each one of these is going to have their pros and cons. Thirdly, determine the class of problem that you want to solve. Test many algorithms within the class. Algorithms are all trying to solve the same problem. They just do it in different ways. So it's always good to try out a few. Because it might be that naive Bayesian classification works in the beginning, but you need to switch to something else, like a deep neural net using TensorFlow. And lastly, follow a software development process to ensure good quality results are being delivered. This is essential for machine learning code because it is really important to test your assumptions, to iterate over time, and to constantly be getting better, as well as staying up with the changes that happen in data. Thank you so much for listening to me talk during this webinar. Again, thanks to Hackerearth, and thanks to everybody for showing up. Here's a bunch of links for you to check out. I wrote a book, Thoughtful Machine Learning with Python. If you want to delve a little bit deeper into this subject, I recommend that you read that because I go through the math as well as the algorithm design. If you want to hear more from me, please feel free to join my email list. If you join my email list, I'll be sending out a free little video course, which are little 5-minute clips. So you just go to matthewkirk.com. I'm running a machine learning course on March 15th with O'Reilly and Safari. You can check that out there. I blog occasionally, and I tweet more often. So if you want to follow me, then please do. So at this point, I really want to open it up for questions. So I'm going to exit out of here and see if there are any questions. Okay. We've got quite a few. Let's see. So how can I save this webinar? I believe that this is actually being recorded, and it will be on YouTube. So I think that they'll post it on Hackerearth. When will it begin? Hello. Sounds good. Great question. How can we judge that the data is insufficient for machine learning? There's a couple of ways of doing this. There's kind of the statistical answer, which is that you have you have an actual variance, or you have like an actual distribution. So there's some like initial data analysis that you can do to determine if there's actually distributions around the data. To be honest, like I think it's more of a gut feeling where if you have 1,000 data points, then most likely you have enough to start with. And I think, I wouldn't get too caught up in like, what is insufficient, because if you have 1,000 data points that are collected by different means, then it's probably good enough to get started. Of course, over time, you might find that you need more data. That really has to do with how well the model is performing. Hi, can I get the slides? Yes, you can. I will tweet out this slide deck because it's on Google Docs. So I will tweet that out. All right. How do PR companies do this? I don't understand that question. So if you could ask that question again in a different way, I'll try my best. Adaptability to change. The stock market depends on a lot of external factors. Yes, it does. So stock market does depend on a lot of external factors. I used to work in finance, and it's an exceptionally hard place to be, especially data analysis, because data is constantly changing, and it's very much a zero-sum game in that one person will be trying one thing while the other's trying another, and it can be very difficult to do anything on. And there's a lot of external factors like fear, things that you can't actually even measure. Is it good to start machine learning with R? Yes, it is. It is totally good. So R is a perfectly fine language. I use it quite a bit, especially since it has good visualization. I think that R has very good visualization, and it's almost unbeatable in that regard. So I think it's fine. If you're going to write anything for production, as in like a web app, or you're trying to write an internal tool, then R is probably not the best bet for that. Okay, what type of learning is used in programming human-like robots? Very good question. So generally speaking, the type of learning that happens in robots it's going to be reinforcement learning, or it's going to be some sort of AI planning, which is so let me explain this. Artificial intelligence versus machine learning. Artificial intelligence is very much deduction, where you have a plan and you execute on that plan. So the idea is let's say that you have one of those Roombas, a little robotic vacuums. What it does is it has a general idea of what it wants to accomplish, and it builds a plan to accomplish that. Whereas machine learning is all inductive. So it reacts based off of data. So supervised learning, you're looking at XY pairs, but in reinforcement learning, you're looking for state and actions and responses to those states and actions. So if you were to program a robot with AI, traditional AI, it'd probably have a plan that it'd come up with, and then it'd execute on the plan. Whereas in machine learning context, it would just start running around like a crazy person until it figures out what is good and what is bad. So the type of learning that would be used in programming robots would be reinforcement learning. Okay. Hey, Matt, a couple of questions from, okay. I don't see the rest of your questions there, so please ask them again. What is the future of machine learning? What is the, I don't know. I cannot predict the future, obviously, but I believe that machine learning is becoming more and more and more important because what is happening is that there is so much information and so much data around us that if we do not start utilizing machine learning more, then people will be overwhelmed. So that is really the future, and I think it's already happening. Alexa, Cortana, Siri, all of those they utilize kind of a collection of machine learning algorithms as well as AI, just traditional AI, and it's happening. Like the future is happening right now. It's a huge deal. Okay. How much of machine learning, I'm assuming that's deep learning, is done using plain Python libraries like NumPy, Pandas, scikit-learn versus frameworks like TensorFlow and Keras? Which would you recommend for getting an MLDL? Right. So generally speaking, TensorFlow is kind of more on the deep learning side. It's a very good framework. I personally quite like it. A lot of the traditional machine learning stuff is in scikit-learn. There's also GraphLab and a couple of others. I think that really what happens is that a lot of these algorithms are pretty simple in conception. A lot of the good libraries are just optimizing that. So you could actually write plain Python using NumPy, Pandas, and not even scikit-learn and accomplish a lot of this. Personally, if you're going to get started, I'd look at scikit-learn and TensorFlow. Those are kind of the two big ones right now, and it's a good idea. Pandas I personally really like it for data frame manipulation. So if you're going to do any sort of like working with data, so filtering out data or anything like that, Pandas is always great. And if you load Pandas, then NumPy will kind of come with it. So you could do a lot with just plain Python. Naive Bayesian classification is maybe 10 lines of code. I mean, it's not super hard. Let's see. Is there a demand in the market for one-time projects in MLDL, basically freelance market projects? If yes, What are the best channels? Yes. So there is definitely a demand for one-time projects. Gosh, what is it called? I can't remember what it is, but there's like a whole marketplace around finding good algorithms, and I cannot remember it off the top of my head, but if you tweet at me, I'll remember it probably later. Um, there's a ton of demand for one-time projects. So a really good example of a one-time project is the Netflix prize, which, I don't, the people who won it took like 6 years to win it, but there's a huge demand for utilizing machine learning and deep learning. So if you're a freelancer, it's a good good use of your time to learn it. What are the best resources to start machine learning from scratch? Right. So I would say, my book's pretty good for getting started because I take like a test-driven development approach, where I go through how to build machine learning algorithms. There's also some other ones, data science from scratch, I believe. There's that's a pretty good book. Um, there's a couple of others out there. I do believe that if you're a programmer, probably stick with O'Reilly's books. If you're kind of more on the mathy side, then um, there's there's a couple of really good math ones. The Mitchell book is probably the most popular. It can be kind of hard to grasp, so um, those are good resources. How to proceed with satellite image data? Okay, great question. I believe that your best bet with any sort of image data is either you can go two different approaches. So there's the classic computer vision where you use OpenCV. That uses a lot of matrix factorization and that sort of stuff. But the new way of doing it is really utilizing deep learning methods. So when I say deep learning, a lot of people, think it's a new idea, but really what it is it's neural networks that have a lot more nodes in them. Um, so the point is that you can use something called autoencoders to take satellite image data and to extract features out of it. You won't have names to the features, but that's a good place to start with image data. Is just trying to extract features so that then you can do some sort of classifications off of it. What is the best way for data cleaning? Wow, that's a great question. Um, Data cleaning. It really depends on where the data is from. I mean, there's some obvious things like, the data is incorrect or whatever, but or like just, you know, put in incorrectly. I think your best bet when it comes to automated cleanup would be utilizing something like bootstrap aggregation, which is a really interesting technique for selecting samples out of your training data and then building a bunch of different models off of those different samples and then aggregating them all together. So I'd look at, bootstrap aggregation, which is bagging, or you could look at boosting, which is another really good way. The point there is of course you can go through the pain and suffering of cleaning all of your data, but um, yeah, this is just a general idea. It's like go for bootstrap aggregation or boosting. Okay. Suggest some open source projects to start with machine learning. If you're asking for open source like libraries, of course scikit-learn is open source. I think TensorFlow is too. Most of the things out there are open sourced, so I wouldn't worry about open source. How to use machine learning for chatbots? Okay. Gosh, yeah. I think chatbots, that's kind of a new thing, isn't it? Um, Chatbots are interesting. So you could approach it in a couple different ways. You can utilize Markov models. So there's hidden Markov models, which I talk about a little bit in my book. Or actually, there's a whole chapter on that. That's a pretty good method of starting with things like chatbots. I think most chatbots are honestly built using just simple NLP, like Word2Vec is a really good tool for extracting vector information and then taking that vector data and putting it through like an expert type system. So I don't think that they've quite implemented a lot of Q-learning or TD Lambda type stuff, but if you want to go down the way of building a chatbot, it's like probably use Word2Vec and then feed it into some sort of model like Q-learning or some reinforcement learning algorithm. Great. Yeah, I guess I didn't talk about this. How to measure accuracy of a model. So when you utilize cross-validation, cross-validation where you take training data, you split it up into different pieces, and what you do is you have testing data. So you know the X's and Y's, and you go through each one of those, you feed the X into the model, and if Y doesn't come out, then it's incorrect. So accuracy is really just the percentage of correct answers for your model. So it would be like an error rate. Is there any role of statistics in machine learning? Oh my goodness, yes. A lot of machine learning is built off of tons of statistics. It might be a little bit implicit. So naive Bayesian classification is probably a good example. It is probability. So it's all based off of Bayesian probability, and so that's built off of that. Hidden Markov models is based off of probability. I mean, maybe not statistics per se, although actually, I take that back. So clustering is usually built off of statistics with measuring the distribution. Bootstrap aggregation is a statistical type model. There's statistics everywhere in machine learning. And which method and platform is best for it? I don't know. What are the machine learning projects where we can apply the knowledge, and how should we approach the problem? So I believe what they're asking is what sort of machine learning projects can we apply knowledge? I mean, there's tons of different applications of machine learning. The point is really, if you're trying to build an insight based off of some pattern that you've recognized, then most likely, machine learning is a good candidate. Hopefully that answers the question. Why do you think most models fail in production even if they perform well in development? Oh, that is a great question. So a lot of times people will build based off of a snapshot of data. So for instance, I've built sentiment analysis models before where we just collected a bunch of Twitter sentiment and tagged it, and that worked really well. But the problem is that it was focused on a subset of Twitter users, so it didn't perform well over time, and we had to end up changing it because people are different depending on what they're tweeting about. So production data is interesting because it's like there's a human factor, and machine learning models are really only as good as the data that you feed it. So if a human comes in and says something completely out of the ordinary, then it will most likely not work. And humans are a little, maybe a little unpredictable. Okay, hi, I'm creating an online survey, and at every step there will be a suggestion given to the user regarding what is the right product. Is Python a good thing for this? Yes, very much so. Python is a very good choice for something like that, especially since an online survey is web app, so you could build that in Flask or Django or whatever. But good, yeah, definitely. Okay, what are the machine learning? Okay, so I already talked about how AI is different to machine learning. Again, the major difference is deduction versus induction. So Sherlock Holmes is a deductive genius, not an inductive. So AI is Sherlock Holmes, whereas machine learning is kind of more, if you play video games, assuming some of you do, it's kind of like mashing buttons until you figure it out. So that's kind of the big difference between the two. Okay, suggest some open source projects to start with machine learning. Yeah, I mean, scikit-learn, NumPy, I've kind of already talked about those. Hmm. Yeah, okay, may I get the slides? Yes, you may. I will tweet the slides out for everybody to see. Aha, okay. How is reinforcement learning different from supervised learning? Um, Great question. So supervised learning is really when you work with X's and Y's. So like you have an X and a Y. Um, Reinforcement learning is when you have yet another variable. So you have an X and a Y, but you're trying to maximize a reward. So call it a Z or something like that. Um, Again, supervised learning is kind of a snapshot in time. Of course, you can turn just about any supervised learning model into a reinforcement learning model, um, but the point is that reinforcement learning is designed to be run over time. Okay. What are the use cases of machine learning in B2B businesses? Great question. I've seen machine learning used for all kinds of different things. Fraud detection is actually a very big one. Portfolio trading, which I guess that's not B2B. Um, hmm, I mean, it depends on the B2B business, but there's a lot of applications in B2B. Let me think. Email sending is kind of one, so that's a big one with like CRMs and that. You can optimize like when you should send emails versus not. Lots of applications. What's the process that should be followed for algorithm development for machine learning? Yeah, okay. So like whenever you're developing code, like I think it's just a good idea to write unit tests. And specifically, like machine learning is interesting in that it's not, yes or no. It's kind of like yes with a probability of whatever. So when you test and write machine learning code, a lot of the time you just test the seams around the algorithm, and then there's a statistical test as to like how accurate the model is or how precise it is. Um, so so yeah, that's how I'd go about it. Okay. How much data one should keep in hand to make a good prediction? How can we purge old data? Great question. A lot of so there's these meta heuristics that I've talked about before, bagging, so bootstrap aggregation and boosting. These are really good at determining what is relevant and what is not. Of course, you can always do like some sort of exponential decay where you weight recent occurrences higher than old occurrences. Um, I think to build a model, you need at least 1,000 data points. And at the top, like depending on what type of a model you're building, what sort of how complex it is, you might get up to 50,000 or 100,000 data points. Once you get over that, then it's kind of into a different territory because you don't want to put too many data points into it because then you'll start overtraining. And that's just basically back to where we were before with ifs and else's. My friend says machine learning will cost everybody their jobs. How do you feel about this? Sure. I mean, I think machine learning will cost a lot of tedious jobs. I agree. But if you look at how cars are manufactured, they're pretty much all manufactured by robots now. So I get it. Like there was an economist in the 1800s or something that basically said that we weren't going to have jobs and because the tractor existed. And what ends up happening, I feel over and over again, is that we make a leap in technology, and then there's a bunch of people who need to, work on the technology. So there'll be plenty of jobs for us to work on machine learning. It just won't be tedious jobs like answering emails. Okay, how many more questions do I have? Let's see. What are the machine learning projects? Okay. Um, what is a good language for machine learning? Python, probably a good language to get started. Kaggle, that's right. Yeah, that's what I was thinking. Yeah, I think Kaggle's a pretty good platform to start out with. Is there any framework for machine learning production deployment? Ah, great question. No, there is not. Not really. I mean, uh, machine learning code is like any code, so therefore, deployment and all that, you're going to do it through Capistrano or Chef or Puppet or however you deploy. Okay. I have 100 data sets in hand. How to convert that 100 into 10,000 data sets? Um, I don't know exactly what you're trying to do. Maybe you could reword the question and I can try and answer it. Um, as you pointed out, collecting data during production is the new data collected used to fine-tune the production model. Yes. Right. Okay. Yeah. Online learning. Exactly. So you can do it two different ways. There's online learning, which is you're basically collecting data over time and feeding it back into the model. Or there's also offline learning, which is pretty much where most people start. Um, Offline learning, basically the idea is that you want to collect some sort of accuracy metric, and if your model works in production, then like don't change it. But if it doesn't, then the point is to either build some online learning or pull the data down and work with it offline. What are the drivers for using deep learning algorithms while driving insights from the data? I mean, honestly, the drivers for using deep learning algorithms have everything to do with they're agnostic and they work fairly well, and we have enough computing power to do it now. So that's kind of what's driving all of that renaissance right now. So I mean, they're not unlike any other machine learning algorithm, though. Have you worked on some open source machine learning project? Yeah, I mean, I've done like little things here and there, but never like, I'm not like a contributor to SciPy or scikit-learn or GraphLab or anything like that. But I do like try to send pull requests up, if I run into an issue. Why is naive Bayes so naive? That's a great question. Um, so if you read my book, I'll go through all of this, but naive Bayesian is basically because they make a big assumption as to like how data is because Bayesian analysis and Bayesian probabilities, like naive Bayesian classifier basically just uh, glosses over a lot of things. It works, but it's like it almost feels like it shouldn't. So it makes a huge assumption. But I won't get into that right now. I'm new to ML development, trying to understand how ML. Right. So the difference between machine learning development and general software development is that you have this added complexity of building an accurate model. So you kind of have to know how to write software as well as building a statistical model. So like it's just more complicated. Um, okay. Hey, if my data points are increasing every day, can I use the additional data to train my existing model instead of training on the entire data set again? Yeah, so this gets back to the online training. So there's some algorithms out there where you can incrementally add new data points, or you can use reinforcement learning algorithms. Yeah, I mean, like, I think that it's actually good to use fresher data than old data, especially if whatever you're working on is, kind of like Twitter, for instance. Like, you wouldn't want to use tweets of Michael Jackson dying because it's just irrelevant. So yeah, I mean, it depends on the problem, but like, yeah, you could totally do that. Uh, is it better to use Python provided libraries, or should we create our own neural network for prediction? And don't create your own neural net. There's a ton of tools out there. TensorFlow is probably your best for getting into deep learning type stuff, and then there's also like a couple of other just feed forward neural nets. It I mean you can. It's just you don't need to. Any ML you could think of in healthcare? Totally. I've actually worked with some healthcare companies before. There are definitely machine learning applications in healthcare. I think that the major problem with healthcare, actually, okay, so there's a lot of work being done right now around cancer prediction, which is kind of a machine learning algorithm. So there's definitely cancer detection, those sorts of things is very machine learning. Which language is good for machine learning? Python. Uh, let's see. What if we don't have training set initially when we start? How do you build a training set? That depends on the domain. So if you don't have a training set, then it's probably good to, get some people on your team and start going out there and collecting data. So for textual data, how do we determine how much data is sufficient? So a good model for textual data would be entropy. So if you want to maximize your entropy, that's a pretty good one. Okay, I think I'm almost there. Weka is good for machine learning. Yes, it is. It's a little bit old, but it's pretty good. Okay. How to develop presenting communication results of ML models. I think communicating results of ML models, it's kind of an art. Obviously, you want to show accuracy, precision, recall, those sorts of things. But yeah, I mean, it's a little bit of an art. Like, I'll leave it up to you. Okay, so I want to know how to start machine learning as a beginner. Very good question. So there's a lot of really good Coursera courses. So the Andrew Ng course is very good. That'll teach you a lot of the math behind it. After you do that, then start looking at the scikit-learn tutorials, and then maybe pick up a book on how to write it. Okay, being a newbie, where should I begin with this? Is it the theory that I should start learning first, or is it the practical applications of different algorithms? Very good question. So I would err on the side of using practical applications if you're not from an institution. I think the theory can get really it bogs you down. Just understand the conceptual idea behind the algorithms and then try it out. Right, okay, what kind of mathematical background do you recommend before starting out with machine learning? I think you want to have a little bit of statistics background, and you also want to understand probability a little bit. Other than that, like, you can kind of pick up most of it along the way. I'm going to take a couple more questions. I think we're 10 minutes over, and I don't know if I'm going to be able to get to all of them, so I apologize for that, but I'm going to do a couple more. Can you share sample code snippets for machine learning beginners to start with? Yeah, so if you just want some really simple stuff, go to the scikit-learn website. There's a ton of information on there, and probably just look up naive Bayesian classification. That's a pretty good example of how to start. In my book, I do go through it, so you could also pick that up. That's a pretty good start as well. All right. Right. Can you recommend some involved literature on machine learning and probabilistic programming? Yes, of course. So there's not a lot on probabilistic programming, like in terms of books. So Eric Meyer, who did Link and .NET, he's been writing a little bit on probabilistic programming. You can read up on Prolog as well. I think for machine learning, like, the best book is going to be the Mitchell book. So if you just go to Amazon and you type in Mitchell machine learning, you'll find the book. That's kind of the holy grail. If you want to learn about reinforcement learning, it's the book's written by Sutton. That's a pretty good book as well. And they'll go into quite a bit of depth as to how all these algorithms are built. So check those out. Yeah, there are cloud ML solutions available from Azure, AWS, and Google Cloud. Do you use them? What do you like or do not like? Yeah, I forgot to talk about this. So you're right. So Amazon has Amazon ML. There's quite a few out there. Azure, Google, I think has one. Yeah, Google does. Um, they're fairly good. I've used them before. I think, a lot of the same ideas exist. They do have an added benefit of you just have to integrate with an API, so you don't have to write as much code. I do think that there's also they can be a little annoying if you're dealing with a lot of training data and trying to build like a pretty big model. So I mean, it's your mileage may vary. Like I've used it for a company that used PHP because we didn't want to write machine learning code in PHP. So I think they're good. I haven't found them as easy to use as some of the other solutions that I outlined. So yeah, again, like what I said is just, there's a lot of different options that you can go with. Okay, so I have tons more questions, and I'm sorry. Um, if you guys have any more questions, feel free to you can email me too, and I'll do my best here. I'll put my email on here. Um, Feel free to drop me a line. My email is matt@matthewkirk.com. If you want to send me an email, I'll do my best to respond to those. But we've gone 10 minutes over the webinar. So again, I'm very very happy that everybody came. Thanks for coming. Thanks to Hackerearth, and yeah, feel free to drop me a line. And thank you.